let's find a power series for this function centered at x equals 0. Now, we know what this lesson is about. It's about identifying things that could be a geometric series, but looking beyond that context, let's also realize that this structure is strikingly similar to the sum of an infinite geometric series. Okay, we just addressed this, but I just want us to notice the difference between this and this, well, the similarities rather, between this and this. Now, we're going to force this to be that in a minute, but let's also talk about the interval of convergence, and this thing will only work, that was poor language in its explanation, but a geometric series is only going to converge when the radius is less than 1 or greater than -1. So basically, the radius is stuck between 1 and -1. It's sometimes referred to as the absolute value of r is less than 1. Same thing, same idea. Okay, I'm going to erase this one in a second because this is the same thing. So, erasing. Oh, let's undo. How about that? There we go. Now, what I really am going to do at the end of this is identify all the parts. Once we have said this is equivalent to that, and we have beat this into submission algebraically, then we will be able to identify the appropriate parts. And those appropriate parts will be, let's make them green. My final answer will be the sum from 0 to infinity of a geometric series. And a geometric series is this. Now, we've also learned it a different way, where it could be this, not in there, goodness no. There, that's better. R to the n, I was already on the exponent in my head. This and this are equivalent. This is the one we're going to deal with because in ours we're going to just start with the 0th term. It's just going to work very neatly that way. So let me erase this. Gare, there, thanks for letting me do that. Gare, what's Gare? Who's Gare? What we're going to do is force this to look like that. So let's just do that. Let's switch to purple. So I really want 6 over 3 plus x to look like this. Okay, what is this? Well, this has a 1 right there, so let's put a 1 right there. Well, you can't just put a 1 there, right? You have to do the appropriate mathematical things. Let's divide by 3. 3 divided by 3 is 1. X divided by 3 is x divided by 3. 6 divided by 3 is 2. And yes, that's a plus, but let's just keep going with this idea. I need to have it to be subtraction there, so we'll subtract the negative. Now, this is truly equivalent to that because we've beat it into submission to look like this. Okay, you have not changed the value of any of this. Overall, this is the same thing, but you have changed its appearance. Now, you have not changed the overall value of the function, but 3 turned into 1, 6 turned into 2, and x turned into, well, negative x over 3. And in so doing, you have identified that a sub 0 is 2, so obvious, but we'll write it anyway, and that r is negative x over 3. Okay, good to know. Good to know. Which means I'm going to walk over here, and I'm going to write my final answer, and I'm going to write it in green. I also need to find the interval of convergence, though, which we will do. So n equals 0 to infinity of a sub 0, which is 2, and then negative x over 3 to the n. This is my final answer, but there is an interval of convergence that's on its way as well. So this interval of convergence is going to come from the fact that we have this, and it has to be stuck between -1 and 1. So I am going to switch back to this absolute valued thing that we had a second ago. I'm going to treat it like that, and then we're going to go from there. And I'm doing that because this was negative, so it's just going to make it a little bit easier to deal with. So taking this idea to find the interval of convergence, and then going, well, the absolute value of negative x over 3 had better be that. Well, absolute value of negative x over 3. So we're going to have x over 3. It's going to become positive, and that is less than 1 or greater than -1. There we go. That looks like an absolute value bar. This is a -1. We'll multiply by 3, so -3 to 3. This function that was represented here has become a series an infinite series that has an interval of convergence from -3 to +3 for the x values. So come over here, green pen. So my interval of convergence, that's terrible handwriting, is -3 to +3, not including either one of those, because it has to be less than 1, greater than -1, not equal. That's my final answer right there.